Welcome to part 2 of our lesson on if statements in Java. In this section, we explore another type of if construct that can lead to better Java programs when there are multiple branches to consider in conditional statements. After completing this part of the lesson, you'll recognize when to use multi-branch if-else statements and begin to understand how to analyze problems and apply the appropriate type of if statement. Recall in our previous lesson, we looked at a very simple if statement. It allowed us to test some condition. If that condition was true, a set of statements was executed. Otherwise, they were bypassed. Let's now consider other scenarios that would require several different paths through several different sets of statements. Here we have stacked several if statements on top of each other in an attempt to offer different prizes to students depending on how many magazines they sold at the school fundraiser. If total sales top 50, the student will win an iPad. If they only sell 35 or more, they still get an iPod. Moving down the prize scale, if they sell 25 or more, they will win a nice stylus. Prizes continue for the group selling 15 or more until finally there is an option of just getting an encouraging message. Do you see the problem with this code, however? Suppose we sold 72 magazines. Passing the first test, we would get an iPad. Moving down the code, we would also pass this test because 72 is greater than 35. We'd take home an iPod as well. This bonanza of prizes would continue until we cleaned out the place. That was not the original intent of the program. We could change the conditions or tests to make them more explicit. For example, our second condition should be sold is less than 50 or greater than or equal to 35. But then a student who sold 72 magazines would still have to run through every condition, even though we knew after the first test that he or she would not pass any of the others. This type of coding would lead to an inefficient program, one that runs much slower, doing much more work than it needs to. What we really need is something more like this. If the number of magazines sold was greater than or equal to 50, then the reward is an iPad. Otherwise, if the number sold is greater than or equal to 35, the reward will be an iPod. Otherwise, the number sold is greater than or equal to 25, the reward is a stylus, and so on. This diagram won't allow for this type of construct. We need to be sure that once a test has been passed and some set of controlled statements, like winning a prize, are executed, the rest of that code is bypassed. This code will do it. Notice that if the number of magazines sold is 31, the blue line of code is executed, and then the rest is bypassed. But this is considered poor style because of the deep nesting. Imagine if you have 17 different categories of prizes. This code would run quite wide with all that indentation. Let's look at an alternative structure that might do the trick. The multi-branch if-else is ideal when we have many conditions to test for, and each pass through the code would result in only one of those controlled statements being executed. In this example, we have 3 groups of conditions: the red, blue, or green. These 3 statements can be controlled with only 2 tests. The final condition, here shown in green, is sort of a catch-all for input that didn't pass any of the other conditions. Here we test to see if input X is positive, negative, or 0. All numbers in this program will fall into one of the 3 categories. But we haven't seen it all yet. Suppose there is a case where we would want to bypass all of the possible statements. That is impossible here. We need an if-else if that allows for that bypass. Here, every statement is controlled, and to execute any of them, a test must be true for the input. This works well for our example, where we have a message for students earning a grade of A, B, or C, but no executable statement otherwise. Take a moment now to review all of the different ways we can use if statements to control what code does and does not get executed. Create a few scenarios that might require the different constructs we've seen today. In each case, look at how many different outcomes are possible, like in the magazine sales, where we had 4 different gift levels. Does your code need the option of bypassing all the conditions? This was not true when we were displaying whether a number was positive, negative, or 0. It was true in the case of students earning an A, B, or C. In all cases, be on the lookout for redundancy. Are you testing for some condition more than once? Perhaps you can combine tests or reorder them so that does not occur. Now that you have seen a wide variety of if statements, let's return once again to our game and the problem of coloring our avatar based on the current position. We have 3 conditions: purple, red, or green, and every player will fall into one of these conditions. The code should not allow for a bypass here. Think you're ready to tackle this one? Let's assume the player's position is given as xy coordinates, p1.x and p1.y. Note that positive x times positive y equals positive result, northeast quadrant, and green. Likewise, a negative x times a negative y also will give you a positive result, indicating the southwest quadrant, also green. Positive x and negative y multiplied together will result in a negative number. This means you're in the southeast or red quadrant. Negative x times positive y, also giving a negative result, shows you are in the northwest or purple quadrant. Try writing the code, keeping all that you've learned today in mind. Did you come up with something like this? The 2 positions that color the avatar green can be grouped together by testing to see if the result of the multiplication of p1.x and p1.y is positive. If it is, the color of the avatar is changed to green, and that position will not be tested any further. Otherwise, or else, we can check to see if x and y are not the same sign by testing p1.x. Notice that although p1.x will be positive for an avatar in the northeast quadrant, that has already been colored green and won't be tested again. Finally, there's no need to test for this last case. If an avatar isn't going to be green or red, it must be purple. These tests could be rearranged in a number of ways. For example, testing p1.y to see if it was negative in that second condition. But the best structured code would only need 2 tests or conditions to discern between these 3 groups or locations, the green, red, and purple. Consider trying some of the code walkthroughs for further practice. This concludes our lesson on if statements in Java. Now that you've completed this part of the lesson, you should recognize when to use multi-branch if-else statements, as well as better understand how to analyze problems and apply the appropriate type of if statement. With your increased knowledge of conditionals, you've added to your growing ability to write Java programs in Android. Consider trying some of the code walkthroughs for further practice.